You've got a table. Okay. And then there's a bowl on the ground. And let me see. Actually, I'll show you one that I've done in the past. So there's a spring which is mounted to like the ceiling, right? Here's the ceiling up here. And there's a hammer which is got a pivot right there, and then the spring is compressed. The spring is released, and the hammer swings around down to this position, hits a ball, okay? And then the hammer continues on with a follow-through. The ball goes this way, goes through a loop. There's got a loop in there. Okay? Then it goes up a ramp. Then it goes into projectile motion.
Come on.
That question was on, yeah, that was on last year's exam.
Wait, last semesters or last?
Maybe last year's, last semester's. I can't remember.
There's always a variation of that question.
Okay, so you're like, oh, that's crazy, but it's not. It's actually pretty simple because I'll show you. I'll write the models on there, and you guys can, in a group or whatever, you can just make up some values and bring some.
What's going on? That's better.
Okay, so this is what we got. We got a spring. We got a hammer, which is held up against the spring, so the spring's compressed, right? It's released, so the hammer comes down, swings down to its lowest position, it hits a steel ball. The hammer continues on through a follow-through, which you would probably expect, right? If the ball's not too massive. Then the ball goes through the loop, and then goes over the ramp, and then into the target.
You have to calculate the distance of all of it.
Yeah, so it's just COEM.
That's just a lot of work.
It is a lot of work, yeah, but it's like, this is like, well, the Assembly Learning Goals it is. So it's COEM for this thing to swing down, right? Then it's COM when it collides. Then it's COEM again, or there could be UCM, Uniform Circular Motion, because it's going in a circle. Like I could ask, like, what force does the ball apply? Or I could say, the ball just makes it through the loop, normal force is 0 at the top. How far do you have to pull back the spring for that to happen, whatever. And then it's PM, because it's launched at an angle to a target. So that's a pretty standard type of question. Yeah, people do well on it because just draw your energy bar graphs.
Is it just one question?
No, it'll be like 5 or 6 questions probably. And each question will be multiple parts. So this right here is 1, 2, 3, 4 learning goals in that one question.
If you wanted to make it even harder, you could have a section between the ball getting hit by the pendulum and going up the loop-de-loop where there's friction you have to account for. So there's deceleration.
Yeah, so we could say like even here it hits a rough patch and it decelerates. So there you could use work energy theorem.
The table breaks.